So, good evening, guys. Welcome to our session in here for today. I hope all of you guys are doing really good, right? So, let us get started with our session in here for today. And the session that we are basically expected to conduct in here for today, it is revolving around this topic for day 21, which is time series analysis. And this topic is basically one of the most important topics with which you guys are expected to move ahead with because this is uh, a separate topic, right? This topic is something which is finding its usage differently from the other algorithms or the other data that we have taken into consideration. So, up till this moment, we have basically dealt with all of the portion over here, and time series data or time series analysis is basically something with which you are expected to be very clear with, right? So if you have a time component in the data with which you are expected to move ahead with, then that is basically something which is called as time series analysis, right? Or that is basically something which is moving ahead with the time series portion. So what happens is that it is very obvious for you to understand that the real world data or the real world portion with which you would be moving ahead with it will have time series component in it. And for that portion or for that scenario, it is very important for you to be clear with this particular ideology or to be clear with this one particular portion, right? And from next day onwards, right? I mean, tomorrow we are not having any session, so the next session that we are having, it would be on Tuesday, Thursday and Friday. So next week is the last week that when we would be having our sessions, right? And 2nd of April, 4th of April, and 5th of April, 2, 4, 5, right? These are the 3 days when we would be having the last three sessions. And this is expected to be like what you can say the last portion when we would be dealing with next week. So, before we start any important project work, I wanted to complete this course curriculum this week. Then you are having holiday tomorrow on account of Good Friday. Saturday, Sunday, you are having break, right? On Monday, we are not having any sessions. So you are having 4 days straight in a row, right? So you are having Friday, Saturday, Sunday, Monday, 4 days straight in a row, and after that we would be dealing with the coursework. So you are getting like a good amount of coursework, or you are getting a good amount of time over here to deal with the other things or other portions, right? To be honest with you. So today let us complete this time series analysis with great efforts, and after that let us resume and let us move ahead with this particular portion with the revision of projects work over here, right? So let us get started with this thing. So time series analysis is basically involved in modeling or studying the data points that are collected over a particular time, right? With the aim of understanding the trends, patterns that we are expected to move ahead with and making predictions about the future values. So it finds its application in various domains like finance, economics, weather forecasting, and much more, right? So there are different types of models, ARIMA, SARIMA, which we would be kind of dealing with today. So take a minute, first of all, to go through this. And typically, stock market data is the data that we are expected to model over here. So whenever there is a time series component in the data that you are kind of working with, then that is basically something which moves ahead or which considers this particular portion over here. 30 seconds, guys, for all of you to move ahead with this particular portion. After that, today we have a lot of live coding also, right? If time permits, we can have two live coding sessions too today because the topics that we are having, they are in themselves having a lot of coding over here. Now, after this is done, there is a really famous model called as auto regressive integrated moving average, ARIMA. And this is a very famous model which combines two things. First is auto-regressive component, and second is the moving average component. And as some of you guys are dealing with stock market data trading, you will know that moving averages play a very pivotal role over there. So in this particular model, what we are doing is that we are basically taking into account the auto-regressive components. And with the help of those auto-regressive components, we are basically trading in the markets. Like you can take predictions over here also. So what happens in here is that you are basically taking two components. There are three parameters. First is P, which is auto-regressive order. Then there is D, which is degree of differencing, and then there's Q, which is moving average order. So what basically happens over here is that you are basically taking all of these portions, all of these things into account. And then based on that, you are basically expected to move ahead with the next part or next portion over here, right? So take your time for this, read what is this ARIMA modeling all about. Let me know about it, and then we can kind of move ahead with the next portion. After that, there is time series forecasting. What is exactly that about? So it is about uh, using or creating a statistical model to predict the future values which have time series component in them based on the present values. So predict the number of incoming and churning customers. That is the first use case that you can kind of move ahead with, right? Then the second use case that you can basically move ahead with, it is revolving around a section, or it is basically revolving around to explain the seasonal pattern in sales. Third thing over here is to detect unusual events like effect of magnitude on Earth or something like that, earthquake and something like that. And to make an estimate of the newly launched product on the number of units that are being sold over there, right? So take your time, go through this, and feel free to let me know if I can help you in anything over here, right? Now, after this particular portion is done, the next is that there are these many components in a time series data. So the first part that you are expected to understand over here, it revolves around this particular trend or this particular section over here, right? So trend is basically showing the general direction of the time series data over a long period of time. A trend can be upward, downward, stationary, it depends. Seasonality is basically something which refers to some advanced concepts over here. So in seasonality, what is happening is that it exhibits a trend that repeats after a particular time, like seasons are repeating in a cycle, right? In a similar way, in a particular cyclic manner, if the things are changing, then it represents or the data is said to have some seasonality in it, right? So you should be like, if you are telling to an interviewer that, okay, I have been working with time series data, then it is very important for you to know these two terms, because I'm 100% sure in some or the other interview you will be either asked to tell what is the meaning of trend or seasonal, right? So take your time, go through this, and let me know if I can help you in anything. It's 30 more seconds, guys, then we will move ahead with the next portion over here. So now after this particular portion or after this particular part is done, the next is about this cyclical component. So these are the trends with no set repetition. So over a particular period of time, the cycle refers to ups and downs, bottoms and slumps in time series data, like in business cycles. So these do not exhibit any seasonal variation. So in seasonal variation, what happens is that definitely during the season of Diwali, there is going to be an increase in the demand for clothes, right? Also, there is going to be a period where there is expected to be a decrease in the clothing part. After Diwali, do you think that there is a great demand for clothing? No, right? But the same thing is repeated over this particular portion, right? In cyclical component, it's more related to businesses or stock markets. It may happen that a particular stock is performing very, very, very well, and it may happen that a particular portion is not performing very well, right? So I mean, it depends on the scenario. It totally depends on the scenario and the portion with which you're. Now, after this is done, there is something called as irregular variations. So irregular variations are basically the variations in which there is, obviously, as the word is saying, there are no, and they are unpredictable, they are erratic, they may or may not be random, they are totally irregular in nature. And when you are kind of moving ahead with this type of trend or this type of pattern, then it is very important for you to understand that these portions can help you as well as they can have some problems in some scenarios. right? Now, after this particular portion is completed, the next thing that I have for all of you guys, it is basically revolving around the portion of ETS decomposition. So it is used to separate. ETS stands for error, trend, and seasonality. So it is used to separate the different components out of the time series data, right? Now, after this is done, there is ARIMA model, autoregressive integrated moving average. This model is there for time series forecasting. There is PDQ, which we have seen. What is it? So autoregression is a regression model, which you already know by now, right? Then there is this autoregressive component that refers to the use of past values in the regression equation. After that, there is IT, which is integration. And what happens in this integration portion is that you use the differencing observations, right? By subtracting the observation at the previous time step. So first of all, you read this much section, then we will go with what is integration, moving average, and then types of N model. So first of all, you go through this and obviously let me know if you are having any questions or doubts on this. Now, what is happening over here is that there is integration component over here, which uses the difference of the previous output and the current output, and whatever is the difference, you basically get the portion from that, right? Then there is moving average Q that is available over here, right? MAQ, which is a model that uses the dependency between an observation and a residual error from a moving average model applied to a lagged observation model, right? So this is also something which is very interesting. And after this particular portion is done, the next thing over here with which you are kind of expected to move ahead with, it is basically revolving around the section, or it is basically revolving around the part that these things, there are different types of ARIMA model, right? So there is a normal ARIMA, first of all, types of ARIMA model. And the first is normal ARIMA, which is non-seasonal autoregressive moving average. Then there is seasonal ARIMA, and there is Sarimax, which is seasonal ARIMA with exogenous variables, right? So now after this is done, you can read this pyramid auto ARIMA later on. Let's move ahead with SARIMA, which is seasonal autoregressive integrated moving average, and it is one of the very famous variants of this given portion that is available here, right? So what I want all of you to understand from this particular portion is that the time series data is basically all around us, and it is our responsibility to, what you can say, uh, identify that there is a time series pattern or there is a seasonal pattern in the data with which we are working. And then based on that, we are expected to move ahead with the later portions. Now, after this is done, there are different components in a Serima model: seasonal component, autoregressive component, integrated moving average. So it's just the seasonal component which is missing in Arima. So what is happening in the seasonal component is that uh, it is very important for all of you guys to like kind of get an idea about this, right? So what I want all of you to understand is that the seasonal part could be daily, monthly, yearly, quarterly. It depends on the scenario, and you can specify that date time component over here as well, right? Now, after this is done, there is autoregressive component which you can uh, take a minute to go through. Now, after this is done, the next part is the integrated component, right? Which you are expected to move ahead with in here. And the last is moving average difference. So these components are basically the things that will really help us in getting an idea about the next portion or about the next thing. Now, after this is done, the next portion in here with which you guys are kind of working, it's revolving around the seasonal differencing. So before we jump into Sarima, it is very important for you to understand seasonal differencing, which is the process of subtracting time series data by a lag that is equal to the seasonality. So this helps you to add that seasonal component, and it is generally denoted by D. So you already know what is PDQ. It is denoted by capital D, which is the seasonal difference over here. And now after this is done, the next thing in here is this. The notations that are used over here, you can take a minute for going through this. And these things are basically something which will really help you in getting an idea about the given portion. And now after this is done, these are the use cases of Sarima, right? So in economics, in retail industry, in energy, healthcare, in any type of portion that I'm highlighting over here, if you see that there is any time series data with which you're working, then I think you can definitely move ahead with this particular portion over, right? 30 seconds for all of you guys to read this and let me know if you are having any questions or doubts on this. And now after this is done, there was something called as profit over here. So it is basically a ML forecasting tool. I have not written a lot about this profit. So it is a forecasting open source forecasting tool developed by Facebook. You don't have to pay any money to use it. And this is basically something that can really help you in some sections or in some portions, right? So you can read it. It employs an additive model that decomposes time series into trend, seasonality, and holiday effects, enabling easier interpretation and forecasting. And this works by fitting piecewise linear and logistic growth curve to the historical data, capturing the trend changes and seasonal fluctuations. Take your time for this, right? And then we will move ahead with the next part. Now, after this is done, the next is about the profit tool versus the traditional time series model, right? Profit offers a lot of advantages like simple configuration, interpretation, handling missing data and outliers more effectively, and automatically detecting and modeling the change points of the time series data. But it will take like a really lot of time to show the practical demonstration for this. Any which ways, I have two live coding sessions scheduled for today. So let's see how much we are able to cover up. After this is done, there is something which is called as MLOps P6. So it refers to the practices and principles for managing and deploying machine learning algorithms. And MLOps is one of the most sought skills nowadays, to be honest with you, right? So you can read about MLOps portion quickly. It is mainly concerned with the deployment of that ML algorithm into production with which you are kind of expected to work with. After this is done, the next part over here is uh, the implementing challenges that you have. So developing and training the model, version control, tracking the changes of the models on the data, automating model performance. So these are some of the challenges. Like if somebody is asking you, that is why I added this in the document over here. Again, you can take 30 seconds for this. Generally, as you naturally work with the problem in industry, you will realize that this is the part. But what happens is that they ask these type of questions in interviews. So you should quickly get an idea that this is the answer. That is why I have added these things. After that is done, here are the challenging and the best practices, how to pre-process the data, what are the evaluation metrics. You can quickly go through this because the model document is already completed. You can take a minute to go through this and then we will kind of start moving ahead with the live coding session. Let's start coding, guys. Right? There is a file that I will share with you. It is the file that we would be needing for the live coding session. Just Blackbucks coding files. This is the data file. So you can open your Jupyter notebook, download the data that I've shared with you guys, and then we can move ahead with the given portion. Right? So here we can then add time series modeling. So the first thing is importing important libraries. So import numpy as in we import pandas as dd, import matplotlib pyplot as php, and from stats models dot tac dot seasonal, you are expected to import seasonal decompose. Then you have importing the data. For airline data, it is equal to dd dot read underscore csv. And then what you do is that you copy this, paste it over here, and then there is index underscore column, which is equal to month, and then there is parse underscore dates, which is expected to be true. And then you have this airline data frame dot head. So these basically are the number of passengers that you are getting over here. So import this data, take your time, and then we will kind of move ahead with the next portion. Then you have ETS decomposition coming over here, right? So in ETS decomposition, what is basically happening, that result is equal to seasonal underscore decompose airline square bracket passengers, comma, model is equal to multiplicative, and then you have result dot plot. So this is what you can get, decomposition of season, trend, and everything, right? So this is error, right? This is seasonal, this is trend, and this is what you are getting. So it is very fruitful, it is very useful at times to get an idea about this. Now, after this is done, the next part over here with which you guys are kind of expected to move ahead with, it is installing PMD Arima. exclamatory mark pip install emd arima, and it will take some time. And after that, you have importing important libraries. So from pmd arima import auto underscore arima. And then you have import warnings and warnings dot filter warnings ignore. And after that you have fit auto arima function. So step wise fit, it is equal to auto arima, and here you have the airline data with passengers. Where is that passengers? Comma, start underscore p is equal to 1 comma, start underscore q is equal to 1 comma, max underscore p is equal to 3 comma, max underscore q is equal to 3 comma, m is equal to 12 comma, start underscore capital P is equal to 0 comma, seasonal is equal to true comma, t is equal to none comma, capital P is equal to 1 comma, trace is equal to true comma, error underscore function is equal to ignore comma, suppress underscore warnings is equal to true comma, stepwise is equal to true. and printing the summary. So stepwise underscore fit dot summary. And this is gonna help you in the given portion, right? Write all of this portion. So take your time to go through this and let me know if I can help you with anything over here, guys. So I think you should be done with this portion by now. So after this is done, let us get started with the next portion, right? So this is the architecture. We have not fitted the data yet. So here we have performing train test split. So train is equal to airline.ilog colon length of airline minus 12, right? And test is equal to airline.ilog length of airline minus 12 colon. Then you have fit a Surrey max. So from stats models dot tsa dot state space dot Surrey max, you are improving SARIMX Surrey max model is equal to this portion train curve bracket passengers comma order is equal to 0, 1, 1. Seasonal order is equal to 2, 1, 1, 12. And then you have fitting the model dot fit, right? And then you see the summary of that model. So now you can see that this is how that SARI Max model has been fitted over here, right? Take a minute to go through this and let me know if I can help you with anything. And now after this is done, yes, I will share that notebook. Why not? So this is basically the document, right? This is basically the document, and this is basically that coding file, right?